Previously, we talked about LLMs, generative AI, the good, the bad, and the ugly, and what those were, and how they can be used, and some of the pitfalls to look out for. And towards the end, we started talking about how the fact that large language models are large and are trained on a very large corpus, as in everything on the internet or close to, and how that isn't always appropriate for what you might want to do as a business. So perhaps you want to pick us up with that thread, Alex, and see where we go with that.
Yeah. So when people think about Gen AI, particularly the language side of that, LLMs, large language models, really in the same way that Google became synonymous with web search, ChatGPT became synonymous with Gen AI, particularly language-based Gen AI, and that ChatGPT is created and owned by OpenAI as a business, and then was bolted into Bing search by Microsoft, and has been integrated into all sorts of other places and applications and stuff. Become sort of a bit, pretty much ubiquitous, and we're on GPT-4 at the moment, which is the most powerful one, GPT-4o.
Yeah.
And but like all previous ones, like GPT-3, 3.5, and so on, it was trained on everything they could get their hands on. And so, probably, the label on the inside of your shoe was somehow used to train GPT, and that's cool, because I think the ultimate goal here was to a degree successors to something like Google, in that you could ask this agent any question and on any subject, and it would be able to give you an answer in your language, in natural language, and therefore, things like search engines wouldn't be necessarily needed anymore, because why wade through 10 web pages to get the information you want? Why wade through scroll after scroll of Wikipedia when an agent can just nicely summarize it for you? And so there's a degree to which having a large corpus of data is essential to be able to train the language model to work in, say, the English language at all. Simply because these language models are not taught how to speak English. They don't stick a, how to speak English manual in it. It learns the semantics and the structure and the words involved in the English language by taking pages from the internet, transforming them into mathematical representations called vectors or word embeddings, and inferring the structure of the English language that way. So if you only trained it, for example, on Wikipedia, it would be able to speak, I think, very good English, but it would be able to speak Wikipedia English, which is highly formal and probably quite idiosyncratic in quite a lot of places. And so it would be decent, and a lot of the early models were, in fact, trained just on Wikipedia, but that's not really going to help in terms of people typing in more slang-type words in questions, or being able to understand other pages from the internet that are written in something other than the Queen's English, and or standard American English. And so they're trained on everything, partly because of the breadth of information they want to encode, and partly to make sure that they can handle pretty much any language use case. And so we're good, right? But and OpenAI aren't the only gig in town. ChatGPT is one of many large language models. All the big players on the internet have their own versions, and plus there's a whole bunch of other models floating around the place, that all are trained on extremely large corpora, and various different size versions of these available. So you can take any given model and scale it down by reducing the accuracy, therefore reducing the size of the model itself. So the model itself is just a gigantic mathematical entity.
So you mentioned that OpenAI isn't actually that open, and there are alternatives, alternative large models, which are put out by the other tech giants effectively. But that's not all that's been going on, right? There's been a lot more proliferation of models and small large models happening in the last year or so.
Yeah. So you're like an accounting firm, and you want to ask questions about accounting regulation in your country. And you can go to GPT-4 and ask it, and you're going to get an answer. We'll not get dragged into the rabbit hole of hallucinations and accuracy. We covered some of that off last time, and I think we will return to it. But let's dodge that point for the moment and just say you're getting answers, right? Whoopie-doo. Now, GPT-4 was trained on everything, including the life history of Elvis and how toothpaste is made, and probably a bunch of really unpleasant chat on, social networks that's not at all helpful when asking questions about accounting. Now, my previous point with standing on, having a large enough corpus to be able to maintain the sort of semantics and integrity of the English language, and we'll stick with English, but really whatever language you're working in, that you didn't need Elvis and toothpaste and stuff. You just really needed accounting, and you probably didn't need world accounting. You might have only needed UK accounting, and therefore, do I need this terabyte size model? Well, the answer is almost certainly no. In the short term, it costs pennies, fractions of pennies to query ChatGPT. And if you get what you want from it and it is accurate, then there's no problem here. But what if you're an accounting firm that has specific accounting practices, that specializes in a very particular edge of accounting, and that obviously has clients and client data and perhaps proprietary IP or data like that is then used to create accounting documents or compliance or whatever for their clients. That proprietary information and the client and the PII information, the personal identifier information is not and cannot and should not be on GPT-4.
Yeah.
Therefore, you can't ask questions that require any of that context. And from a perspective of that type of professional services firm, that's going to make GPT-4 quite limited. And the same goes for any of the other open models. Now, you can take the first part of that, which is specialization, which is, say, finance-based data, which has its own vernacular. Another probably better example is biosciences and pharmaceutical data. And if you've ever worked in or around pharmaceutical companies, you'd know that when you talk to someone, they'll say a whole bunch of words, all of which you know are in the English language, about 1/10 of which you actually understood, and that was all and or if, because the rest of the words are unintelligible molecule names or something. It's got a very, very well structured, rich, and extremely large internal corpus of data just for that industry, and even for any given part of it, like oncology or whatever. And so there are obvious two areas, financial services and biosciences, to have models that are very, very closely tailored to them and optimized for those. And indeed, if you go onto Hugging Face, you will find models that have been fine-tuned and tailored to those particular industries. And I can imagine you could come up with another 5 easily that would probably fit that bill. And quite frankly, if you just worked in retail, we just have a retail model. There's nothing massively different about the way that retail businesses speak, but they've still got a certain amount of their own stuff, right?
Yeah.
So these models are going to be hopefully smaller, but certainly more powerful for answering questions in those particular domains, which I think is really important. And I think that this is where the future of large language models go. I don't know what you'd call it, medium language models. None of them are going to be small, but models that are trained to maintain as much integrity of the semantics of the language as possible, but eschew a lot of stuff. So you can't ask it where Elvis was born, because it probably doesn't know that, but you can ask it about the tax regulation in Scotland, right?
So effectively, you're talking about you'd have a less general model, and then you're putting in, and then you start to apply your own. You're loading up your own information into it, which is where you get into your RAG, I guess.
Yeah,
which
I mean,
is
so the main methods that people have been using recently are fine tuning, which you can do to GPT, which involves giving it lots of examples of what you would expect, right? So if I say the cat sat on and you would fine tune it to always answer Matt, right? And so you can imagine there are patterns within domains whereby you can fine tune a model to react in certain ways, to use certain language, to give certain types of answers that are well tailored to that. And I think a lot of the a lot of the domain specific models will have used some version of that. And you can do that on any of the models now. And as you point out, that's not the only technique. And there's always ways of updating and retraining models, assuming you knew the way that it was vectorized and trained in the first place. And then you've got retrieval augmented generation, called RAG. And I'm not going to try and say anything other than RAG again, because it's hard to say, which is taking an existing model and feeding it information that it can answer questions about. So you would have a set of documents that are perhaps regulatory or in-house accounting practice documents, and say, take these documents, read them, and then only respond using this information. And you can do this now there's ways of doing it properly on ChatGPT, but you can simply go to ChatGPT right now, say, here is an essay that I wrote. Please answer the following questions using only what you find in that essay. Right. And what that's doing is using the semantic and language based abilities of the language of the model, that have been encoded by reading the whole internet, and using those to be able to produce answers and summaries from a very particular corpus of information, and very much restricting that, right? And because you also presumably want it just from this essay, you don't want it augmented from Wikipedia, don't want other information, you just want it from this particular source. So you can do that now, but what a lot of companies and businesses are doing is loading in large amounts of their own data, or creating models that are surrounded by this RAG infrastructure, that has their corpus of information readily available, fish out the bits that are relevant, give those to the model, and ask the model questions about it. the value of this is that in that scenario, the model itself, GPT, Llama, whatever that is, will not see or ingest that data, right? In theory, it should not be incorporated into the model. And I don't think when you're using GPT remotely via OpenAI or Llama, a hosted instance of Llama, I don't think you can guarantee that that information hasn't been ingested. And I think that's some of the issues that some of the businesses have had where, you know, trade secrets have turned up as answers to someone else's question via GPT, was that it got ingested when it wasn't supposed to.
Yeah.
So the way around that is because, for example, Llama 3 is currently available on Hugging Face. You could host your own version of Llama, even on your laptop, but it will be a very, very light version, a very, very inaccurate version. But if you've got some server space on Azure or Amazon or something, you can host your own version of Llama, feed it those documents, and at that point you've got full control. You can do it entirely within your own VPN, inside your own network, with your own security policies. Not saying there's no other security concerns with doing it, but the one that relates to passing your data to OpenAI is ameliorated, simply because you've got a completely closed system. And that's really where a lot of this is going right now.
Yeah, and you got to feel that that's really one of the holy grails for a company here is, you know, like I want to be able to get my own information in there, and the more breadth of that I can get in, the broader the questions I'm going to be able to ask and get, you know, decent answers to.
Yeah, I'm in the case of RAG, you're not updating the model, right? So there's a fairly complicated bit of infrastructure that you need to enable RAG at scale, right? Because the way it actually works is, because you don't want it, it's incredibly inefficient to pass your whole corpus of data to the model to answer any question. You know, it has to ingest all of that at query time, and then run its inference algorithm against the model for that whole corpus, and that's going to be extremely expensive and probably very slow, right? And there are certain occasions you might want to do that, but it's highly unlikely. So what actually happens is that you convert your whole corpus, your company's documentation, into a similar vector-based form, so word embeddings in a local vector database, which you can think of not massively different from your standard, you know, MySQL, Oracle, whatever you've got in your business. Your standard relational database is just storing data. It just stores it in a very, very specific abstracted form that can't be read by humans, but can be queried for things like similarity. So you can put natural language queries in it. Your initial question: what is the tax policy for this particular area in Scotland? And it will run a similarity query against your whole corpus, bring back documents that relate to that, pass those to the model, and then have the model answer questions on that. That way you get a much more reduced corpus of data to be fed into the model, and it's much more efficient. But you are not A, updating the model, or B, querying your whole corpus at that point. So if your similarity search on your side is not optimal, then you could be missing documents. Right? You could be passing the model information that a corpus of data doesn't have enough information to actually be able to answer that question properly.
Yeah. And you can see the complexities there beginning to grow. You know, we talk about, you know, we spoke before about how GenAI, you know, and you've got these large language models, but actually there's a number of orchestration steps are going on, and this is where people are going now. Like you say, now you want to load up your own data. So actually you've got a number of different steps in there. Perhaps you've got your own, as you say, your own vector database in there. And now there are more and more steps coming in to make the overall experience useful. And of course, each of those steps is going to have its own drawbacks. And like you say, if you haven't got the right stuff and your similarity search on your own document isn't good enough, then it doesn't matter how good the main model is. And so these layers of complexity start to come in, and layers of problems, and you've got to start to engineer those and start to focus on those, and as people are, but it starts to make it more complex, more prone to, I won't say failure, but things becoming less optimal because you've got so many steps, and each of those steps has got to be really good in order for all 9 steps to add up and be half decent.
Yeah, it's like scaling anything else, except arguably harder, more prone to problems, and potentially much more expensive. We've discussed before, you've got this idea where you can produce a cute little analytics app in a Jupyter notebook, or even just whip it up in Excel or something. It does something really, really useful across a set of data. Suddenly you've got someone senior in your company, well, I want that in front of everyone, and you say, well, actually that's quite hard to do, because how am I going to get this spreadsheet out to everyone? If we just send them all a copy of it, then it's still got a query from this central data set, blah blah blah. It's not very scalable. It's not really the right platform for this. This is why we have Power BI. That's going to take a bit longer to do, and you get to this point where you realize there's actually quite a lot more involved than getting that, just having that little spreadsheet. And you can easily get in situations where, as most businesses have done, which is someone has tried to scale that spreadsheet, and it's a big blight in the center of that organization. I think what we have with the large language models is that you can very easily get it to do something that's really quite impressive and solves a lot of problems, just by doing a few clever prompts and stuff, and feeding the right thing into GPT-4. And so you go, well, I want this. I want everyone in my business to have this. And immediately you're like, well, no. Firstly, there's security concerns, firewall security, all that stuff. Then you've got, well, actually, okay, if there's, if we can't do it if we can't trust OpenAI, we have to bring it in-house, which means hosting the model, which means building some sort of bubble around that, infrastructure bubble, an interface around that model, all the routes into it, the right ways to ask it questions, any retrieval based stuff that you've got in there, and then obviously if you've got 20 users, probably isn't that bad. If you've got 2,000, 20,000, 200,000, you're into some serious scaling issues right away, right? And so you're having complex conversations. Well, at that point you go, well, we can't do that. So we go back to OpenAI. And can you do it with OpenAI? Can you do it with Llama? Can you do it with these things? Will they offer you the guarantees on like data privacy and so on? And if you're in a highly regulated industry like pharma or financial services, are you just on the wrong side of the regulation, immediately you start dealing with OpenAI, would suggest that most of those businesses would opt on the side of caution, because the consequences are going to be insane if something goes wrong and the wrong type of data gets leaked, especially for like auditors. So they're not going to be able to do that until some point in the future where some assurances have been offered to the regulators that say OpenAI is able to provide them with that level of insulation. So in the meantime, if you want this stuff, you have to host it in-house. And these guys, your average auditor is not small, right? Yeah. So we have this huge thing now that they've got to build in-house. And that is, has the same, as I said, arguably, more tricky scaling issues than your average, you know, business data scaling problem. Your data lakes, data warehouses, data lakes, and things like internal in intranet and search and things. Everyone knows now how hard this is. Everyone's bored of these conversations about these big ticket data scaling things, and we're somehow secretly hoping it goes away. But unfortunately, you still have to. It's still crap in, crap out. You still have to maintain a high quality data set to be able to feed the model like this with your internal data. That data has to be cleaned and normalized and maintained and kept up to date. There's literally no difference between that and what you've already been having to do, except now you've got this extra layer on top. And to throw into the mix just for a laugh, it will sometimes randomly make stuff up.
Exactly. Yeah.
So then what infrastructure you build around that? How do you safeguard for it giving you answers about regulation, which has very specific, real and clear answers to give to your client, and then it might just be completely fabricated. And that's not an easy, that's a problem that no one's solved yet.
Yeah. So it sounds like there's almost three options there. You've got the use an API provided by a big company like ChatGPT, which has its drawbacks, and you're not really going to get your company personalization. You've got sort of a middle ground, which is to take some sort of smaller model like Llama or other models which are now out there, sort of being called open source models. And then you have to build some infrastructure around it, least of all, the sort of how you interact with it and get your own corpus of data interacting with that. And that sounds reasonable, but still, still quite a lot of engineering in there. And of course, it's all quite new. So that there are as many different answers at the moment. And then there's the third option, which is, well, let's just build our own large language model, which, of course, I think ChatGPT's trained on 175 billion parameters or something. So you're only really going to do that if you're a big company where having a large language model that big, you can monetize in other ways, as in external to your company, because you're probably not so big that building a model and all of the engineering around that and the cost of building it and the servers and everything is only going to pay off if you can monetize that directly, as per ChatGPT or Google and Facebook. They'll be using it internally because they're really big data companies that churn through loads of data. But most companies have got a lot of data but aren't necessarily outward facing with it. So it's probably the first two options where people are going to go, and there's still quite a bit of work to get that to work for you.
Yeah, I mean, there's some scope for building much smaller language models, and perhaps in a very closed domain like biosciences, that's more feasible, especially given that types of questions people are going to be typing in isn't going to be in Twitter slang, and that you can require that your users use a fairly decent language query, so you don't have to train it on all of social media just so it picks up on all the nuances. And so there is a lot of scope for more domain specific models and perhaps very limited internal models. And some businesses will almost certainly do that, the very, very, very big ones. But it takes a lot. It doesn't matter really. You still need quite a big corpus to train that, a lot of parameters. And so whoever does that, is going to have a gigantic GPU farm and pay, spend a lot of money on just generating and then updating and maintaining the model. And as you say, it's hard to see how one farmer, AstraZeneca or Pfizer or someone, they're huge companies, but I don't know the economics, but I find it unlikely that they could make it stack up just for using internally to AstraZeneca. They're big, but are they that big? So I think, yes, you're absolutely right. I think, people are going to be relying on augmenting or updating these, commercial third-party models for the foreseeable future until some of these problems are sort of solved around model size, training, the cost of training and the main specific models really start to proliferate, especially if they're open source. But I can imagine, you know, as a big pharma company, you're not going to trust the next pharma-based model that you put off Hugging Face. You know, like everything else, big corporations are going to want insurance and SLAs and stuff like that. So one way or the other, you know, someone's going to come up with a a pharma model and make a bunch of money out of selling it to the farmers, right? How long that's going to take? Current rate of progress,
about 2
like
weeks.
next week, maybe. I mean,
yeah, exactly.
but I don't know. There's got to be a plateau here somewhere. So it's hard to say right now, but there certainly are models out there that already tackle this.
Yeah.
So we're making pretty strong headway.
Yeah. Whole new world rolling on us.
Yeah. So next time we're going to cover how large language models do not ameliorate or reduce the need for large data engineering. In fact, might increase the need for it.
Exactly. Oh,
good.
See you next time.
Cheers.